Hello and welcome to Wednesday's Science today, Year 5, and we're going to talk about formulations today. Before we get started, let's just make sure you've got everything that you need. So for the lesson you will need a pen or pencil, your science book, some scrap paper and a ruler. It would be great if you could also get a few bits and bobs for the investigation that we're going to do later. For that, you're going to need 4 clear cups or glasses, some squash, orange, blackcurrant, strawberry, the flavour doesn't matter, a spoon, preferably a dessert spoon. So this is the spoon from your cupboard that's probably the middle size one, the teaspoon being smaller and the tablespoon being bigger. And then just a jug of water as well. So if you want to grab those bits now, if you can, do ask before raining the cupboard and emptying all the squash away. Get all that ready if you can, and we'll get started. So today we're going to talk about formulations, but before we do, let's go over a quick recap with some total recall. So what state of matter does each diagram represent? 3 there. Pause and say if you can say out loud which each of those is. So we've got solid, liquid and gas. Solid is where the particles are arranged in ordered rows tightly together and they are fixed and do not move. So they take a solid shape. Think to yourself of a solid that's right in front of you. Second one is liquid. We can see that they are arranged in a random way. They are touching, but they are not in those ordered rows and they can move past each other and move around each other. So think of a liquid. And then the last one is gas. We've got the particles spread out. They're not touching each other. They're moving quickly around. Think of a gas. Okay, let's move on then to talking about pure and impure substances. So one of these diagrams shows a pure gas. One of these shows a pure gas. Which one is it? Pause and have a go. And here comes the answer. So we've got pure on the left-hand side there. Pure left as I look at it. The reason it's pure is because we've only got one particle in that gas. So this could be oxygen gas, it could be hydrogen, could be nitrogen gas, could be argon, and this can go on and on. But we've only got one particle within the gas. An impure substance, in this case an impure gas, is one where we've got more than one type of particle. So we can see in that case we've got the white ones and the black ones mixed together. This could be a mixture like air, where we've got oxygen, carbon dioxide and nitrogen, as well as some other gases all moving around together in a mixture. Next question then. Pure metal or alloy? I want you to decide for each of these 3 which is a pure metal and which is an alloy. Okay, so if you've not paused, pause now, and here come the answers. So we've got pure metal on the left-hand side, the all dark solid, the all dark metal there, and the all white one. They're all the same substance. They're all the same metallic elements. So it could be tin, iron, gold, copper, platinum. Either way, doesn't matter really. And then we've got the impure metal, where we've got a combination of the darker particles and the lighter ones. And this is an alloy. It's where we've mixed different metallic elements to create a new metal. So examples of this are bronze, steel, or white gold, where we change gold to make it silvery, because people like it to look that way. Add things like palladium to the gold to make it the colour that they want. Now today we're going to talk about a certain type of mixture called a formulation. Formulations are mixtures which we make with a specific ratio of substances. So that's our definition. What is a formulation? A formulation is a mixture made with a specific ratio of substances. What do we mean by that? Well, we mean that formulations are mixtures where we're adding a certain amount of one substance and a certain amount of another substance, or maybe more than just the 2. An example of this is squash. So in squash, we make it in a ratio where we use 1 part squash and maybe 10 parts water. So for every 1 of squash, we use 10 of water. If we change that ratio, the formulation doesn't work. It's affected. So if we put too much squash in, the drink will be too sweet. If we don't put enough squash in, if we put in too much water, the drink won't taste of anything. Paint is a formulation as well. If we want to make some orange paint, we might mix 1 part red and 2 parts yellow. If we get it wrong, if we mix far too much yellow and only a tiny bit of red, we'll end up with just yellow paint. The makeup of the formulation is affected if you change the ratio. Medicines. Most medicines are mixtures or formulations. They're made to a very set recipe so that they do exactly what they're supposed to do. So when we buy medicine, something like Calpol or paracetamol, it's got a very set amount of the active ingredient of the chemical that helps take away a headache. It's got just the right amount of that in each tablet, in each formulation. If we altered that formulation, the medicine could become dangerous or it could do nothing. So it's got a really set ratio within the formulation. So is this a formulation? If you make a cake and you always use the same amount of sugar, butter, flour and eggs to make that cake, does that make it a formulation? The answer is yes. When we make a cake, you use the same amount. We use that set ratio of sugar, butter, flour and eggs to make that cake. If we suddenly decided instead of 1 egg we were going to use 17 eggs, we would not end up with a particularly nice cake because we've changed the formulation. What about when I've finished making my cake then and it's time to do the washing up? I want to make washing up water. So I mix, a teaspoon of washing up liquid out of the bottle, put that in the sink, and I add 10 litres of water. It's a bit of a big washing up bowl, maybe just 5 litres of water into the washing up bowl. And that makes a nice soapy liquid that's just perfect for washing my plates. Does that make it a formulation? Definitely, yes. I always use the same amount of washing up liquid and water. If I suddenly decided that I was going to completely change the formulation and use 5 litres of washing up liquid and 1 litre of water, I'd end up with a great slippery, bubbly mess all over my whole kitchen. Or if I changed it to 1 drop of washing up liquid and 50 litres of water, I'd end up with dirty dishes. It wouldn't do the job. So a formulation has that really specific ratio to do the job. So here, let's answer some questions in your book now, please. Title, formulations, and then we've got 4 questions to answer. What is a formulation? Why is a cake a formulation? What would happen if you change the amount of each substance in a formulation? Does the amount of each substance need to be the same as each other? Now remember, the great thing about a recorded lesson is you can rewind and just go back and hear some of that input again if you need to refresh some of that. Have a go at answering those 4 questions in 4 full sentences in your book, please. Right, let's have a little look at your answers then. And I'd like you to tick or fix. So have a look at your answer, and if it's correct, give it a nice little tick. If there's something you want to change, if you've got a purple pen, it'd be great if you could change your purple pen. If you don't, you can just carry on in your normal pen. A formulation is a mixture made up of specific amounts of each substance. A formulation is a mixture made to a set ratio. Formulation. A cake is a formulation because you use the same amount of flour, eggs, sugar and butter to make the same type of cake. You might have used the word recipe in your answer. Cake is a formulation because you use the set amounts in a recipe to create the cake. So what happens if you change the amount of substance in the formulation? Well, it changes the properties of the formulation. It means the formulation won't do the job you designed it to do. So it won't be the same formulation. You'll change the properties of it. Do the amounts in each, the amount of the substances in the formulation, do they have to be the same? No, they don't have to be equal, but they have to be the same every time. So we can use formulations to make smaller or larger amounts of the formulation. So if I wanted to keep the same cake recipe, I've just cooked a delicious cake, very happy with it, but it was so good that all my friends want one, and now I want to make 4 cakes instead of 1. I don't need to change the recipe. I need to change the ratio. I need to change the amounts I use. So what would I do? My recipe gives me enough for 1 cake, but I want to make 4. What should I choose? Option 1, option 2, option 3, or option 4? Pause the video here, read them, and choose the right one for you. Okay, so I'm hoping we said option 2, because with the option 2, we're using 4 times as much of each ingredient. So if I use 2 eggs to make 1 cake, that means to make 4 cakes, I want to use 4 times 2 eggs. So I'd want to use 8 eggs. Let's think about it with paint then. I want the same colour, but this time I only need half the amount. I want the same colour, but I need half the amount. My instructions give me the substance for 1 pot of paint, but I only want to make half a pot. What should I do? Pause, read the options, and choose the one that you think is correct. I'm hoping you said option 4. We're going to use half as much as each substance. So if to make my orange paint, I used 2 yellow and 1 red. Now I want to make half. I'm going to use 1 yellow and half a red. I've cut the 2 parts yellow down to 1 because I've halved it. And I've cut the 1 part red down to half a part because I've halved it. I'm doing the same to each part of the ratio. Right, now we're going to do a little investigation and see what this looks like. So the first job to do is to get a table ready. So I would like you in your books to pause now and copy this table carefully using a ruler into your book. You want 5 columns. The columns for colour and taste. Try and leave yourself enough room to make a short comment about the colour and taste, so don't leave those too small. Copy that into your book now, and I'll be back to guide you through the investigation. Okay, so we're ready for our investigation. Let's have a quick look at our method, what we're going to do. We're going to use a dessert spoon to measure out amounts of squash and water into 4 different cups, shown on the table. We're going to put the cups next to each other and compare the colour of the mixtures. We're going to use colour as one comparison, and we're going to use taste as well, just tasting a small mixture to compare how each of them taste. I'll say now, you might just want to taste a tiny bit. One of them isn't going to be really suitable for drinking the whole thing, so just don't feel you need to drink every last bit of squash that you've got left over. Okay, let me show you then how that's going to look. So I'm going to take my cups and squash and water and spoon all together. I mentioned you might want some scrap paper. I'll show you why. I've just put together just a few little, I've just torn a piece of paper into 4 so that I can mark up each of my glasses and make a comparison across all 4. So for example, here I've got number 1. I know it comes up in reverse for you, but number 1, I've got 1 part squash and 5 parts water. So I'm going to take my cup and then I'm going to use the spoon over the cup. I'm just going to bring the camera down so you can see a bit better. Holding the spoon over the cup so that if any spills, it'll just go into the cup rather than all over my dining room table. So I'm going to pour it into the cup, and I want to do 1 part squash to 5 parts water. So bring in the water, that was 1 spoonful of squash, fill up the spoon and turn it for 1, 2, 3, 4, 5. Okay, drips off. So I've done my first one there, and I'm going to put that one on sheet number 1 so I can have a little look at that at the end. I'm going to do exactly the same for numbers 2, 3 and 4 now, and then at the end I'll be back for a short conclusion. We'll talk about what we've found. So you go away now and do your experiment. If you can't do yours, stay with me because I'll show you my results at the end and we'll have a good look at them. Okay? Okay, so I'm all done. Let me show you what I've come up with. So here was squash number 1. Now, I'm going to enlarge the camera for you. So this was 1 part squash to 5 parts water. So colour-wise, looks about right. It's about the correct colour for squash. I'd call it sort of about lemon colour, something like that. Now the all-important taste test. Well, I don't know about yours, but my number one tastes like a perfectly decent glass of squash. Not too bad at all, just like it should. It tastes a bit of orange, but not too sweet at all. Now let's have a look at number two then. Here's number two. I'll hold that one up to you. That's 2 parts squash to 10 parts water. Let's try that one. Well, let's look at colour first, and let's start making a comparison. Well, I find it very difficult to actually see any difference between them. They look to be identical colour. Taste-wise, identical as well. They taste exactly the same. Right, so our first findings are 1 and 2, same colour, same taste. Let's have a look at number 3 then. Here's number 3. This was 3 parts squash, 15 parts water. Tastes like orange squash, perfect taste, just the same really. Colour-wise, here we bring it in next to number 2. I don't know about you, but I can't tell a difference. I'd say that's orange squash, regular orange squash colour. Tastes about right as well. So then, number 4, I had 5 parts squash, 1 part water. Here's number 4. Colour-wise, very different colour. Looks like the squash just out the bottle, really. The colour hasn't changed at all. It's much thicker. If I compare it to number 1, here's number 1. Here's number 4. Number 1, number 4. Number 1 tasted like delicious orange squash. Ah! Number 4 is horribly sweet and too sugary. Not very nice at all. Far too much squash, isn't it? So if we come back then and we start to look for some conclusions, let's see what we can say. We've got our findings. Pop your findings into your table. And let's have a little look. What did you notice about the colours of 1, 2, 3 compared with number 4? So we can make a statement about numbers 1, 2 and 3 in comparison to number 4 when it comes to colour. Then 2, what did we notice that was different about the taste? Question 3 is going to ask us, why do we think this happened? Question 4 is a challenge. If you think about it, if you use a squash that was double concentrate, what would you have to do differently? I'd like you to pause now and have a go at answering those questions in your book. Okay, did you have answers like this? Well, the colours of 1, 2 and 3 were lighter than cup 4. The colours of 1, 2 and 3 were the same, and cup 4 was different. It was much darker. The taste for cups 1, 2 and 3 was much weaker than cup 4. Or you might have switched that around and said the taste of cup 4 was much stronger than 1, 2 and 3. 1, 2 and 3 for me tasted like perfect orange squash. Number 4 was not so good. Cups 1, 2 and 3 had the same ratio formula, whereas cup 4 had more squash and less water. There's our reason. 1, 2 and 3, we used the same formulation. 1 part squash to 5 parts water. Cup 2, in comparison to cup 1, I just had double the amounts. And cup 3, I had treble the amounts of cup 1. So I went from 1 part squash to 3 parts squash. I went from 5 parts water to 15 parts water. Then when I came to cup 4, I changed the formulation completely. In fact, if we look at it, we swapped the formulas round. I went from 1 part squash to 5 water, to 5 squash, 1 water. So I switched them over. It changed the formulation. I've not ended up with orange squash. I've ended up with a slightly weaker concentrate that, don't drink it, it's horrible. That is not doing the job. It's not the formulation we wanted. So that's our conclusion for today. That's how we worked out formulations. Challenge activity, if you want to take this a little bit further, a little optional extension. Give examples of as many different formulations as you can, and can you put them into solid, liquid and gas? We've looked at a liquid formulation today. Can you think of any solid examples? Real challenge. Can you think of any gas formulations where gas are made into certain ratios to create a perfect mixture of gas? Might be something you need to go away and research yourself. But that's it for science for today. It's been a great lesson. I hope you enjoyed the experiment, and I'll see you next time.